Question 1, Part E. Use the substitution u equals 25 minus x squared to evaluate the integral of 2x over the square root of 25 minus x squared dx from x equals 3 to x equals 4. Starting with the substitution u equals 25 minus x squared, differentiate u with respect to x. So we get du dx is equal to negative 2x. Next, I'm going to make 2x dx the subject because later on, I'm going to replace 2x dx in the original integrand with its equivalent in du. So rearranging this equation here to make 2x dx the subject, we get 2x dx is equal to negative du. Next, change the limits of integration so that the limits are in terms of u. So when x is equal to 3, using the substitution here, we get u is equal to 16. And when x equals 4, u is equal to 25 minus 4 squared. So we get u is equal to 9. So the original integral, so that's the integral of 2x dx over the square root of 25 minus x squared from x equals 3 to x equals 4, becomes negative integral from u equals 16 to u equals 9 of du over the square root of u. Notice that the limits look like they're back to front. In other words, the lower limit is larger than the upper limit. And we can fix that by multiplying the entire integral by negative 1, which turns the negative integral into a positive integral, but we compensate for that by swapping the limits of integration. So this negative integral here becomes a positive integral, but the limits are from 9 to 16 rather than from 16 to 9. So the integral now is the integral from u equals 9 to u equals 16 of u to the power of negative 1 over 2 du. Notice that I changed the square root into its equivalent using index notation. Now we can integrate u to the power of negative 1 over 2. And we get the square root of u times 2, or u to the power of half, divided by half, which is where this 2 comes from u equals 9 to u equals 16. Applying the limits of integration, we get 2 multiplied by the square root of 16 minus the square root of 9 in brackets, and root 16 is 4, root 9 is 3, 4 minus 3 is 1, 2 times 1 is equal to 2.